Here's the notes on 5.2. I hope you've got a clean copy of these printed out. If you're able, let's dive in. The question we're asking today is how much information would you need about two triangles to be certain that they were congruent to each other? We've talked about what congruent triangles means, okay? We've talked about the fact that one triangle could fit perfectly right on top of the other. I mean, they might be spun around or facing in different directions, but you can find a way to fit one exactly on top of the other. If I tell you that triangles are congruent, if I tell you that up front, that the triangles are congruent, then you know that for every side of one triangle, there is a corresponding congruent side in the other triangle. And for every angle in the one triangle, there is a corresponding congruent side in the other triangle. But what if we don't know if two triangles are congruent? Nobody's telling us that, for instance. Okay. How could we find out? How could we determine that the two triangles are congruent without necessarily measuring all three sides, all three pairs of sides, to establish that, oh yeah, I've measured all three pairs and they're all congruent, and I've measured all three angles and they're all congruent, all three pairs of angles? Is there a way to get away with less information than that and be certain that the triangles as a whole would be congruent? Okay, so let's just get into some examples here. I think you'll see what I mean. For instance, would one pair of congruent angles be enough? In other words, if I had two triangles and all I knew about those two triangles was that for sure there's one pair of congruent angles. I don't know about any other angles or any other sides. I don't know if any other pairs of angles are congruent. I don't know that they're not congruent. I don't know that any other pairs of sides are congruent. I don't know that they're not congruent. The only thing I know is I've got one pair of congruent angles. Well, here's a drawing where I've got a 60-degree angle in this triangle and a 60-degree angle in this triangle. Clearly, those triangles don't appear to be congruent, right? I think this is a convincing enough diagram to suggest that if all I knew about two triangles was one pair of congruent angles, those triangles would not have to be congruent to each other, right? I mean, look at all the other sides. They don't seem to be congruent to each other at all. Well, what if I had two pairs of congruent angles? And that's all I knew for sure about the triangles. Would that be enough to be certain that the triangles were congruent? Well, here's another picture suggesting that the answer is pretty obviously no, because here's a 20-degree angle congruent to that 20-degree angle. And then here's a 70-degree angle congruent to that 70-degree angle. But look at the relative sizes of the sides of those two triangles. Clearly, the triangle on the right is bigger along every side length than the triangle on the left. So it's not going to fit perfectly on top of that triangle on the left. And so two pairs of congruent angles is not enough to know that the triangles as a whole are congruent. What about three pairs of angles? Well, that's a no also, and I don't even have a picture for that. Or actually, I do have a picture for that. And it's the same picture here as the two angles, because look, if I've got one triangle with a 20 and a 70-degree angle in it, those two angles add up to 90, right? Subtract that total of 90 away from 180, and there would have to be 90 degrees left for that angle there. And the same would be true of this triangle on the right. There would have to be 90 degrees left for that angle there. So here's a picture now where I've got three pairs of congruent angles, but that really doesn't change the picture at all. Still, all of the sides of the triangle on the right are clearly bigger than all of the sides, all of their corresponding sides in the triangle on the left. Okay. So, and at this point, you might be asking yourself, why are we going through all of these examples if it's all just no, no, no? Is he just going to finish up by saying, no, we need to know all all three pairs of angles and all three pairs of sides? Well, the answer to that is no. There are situations where we can know less information than all three pairs of sides and all three pairs of angles, all of that, and be certain that the triangles are congruent. So let's keep looking at some other examples. How about one pair of congruent sides, like in this diagram here? Okay. Well, here's two triangles, and I've got that side marked congruent to that side. And I'm not even trying to fake you out here. I mean, don't those two segments really look like they are congruent to each other? Sure, but the triangles as a whole, no. Okay. How about two pairs of congruent sides? All right. I think you would agree that this segment that I've marked congruent to that segment really, truly, probably is congruent, and that these segments here really, truly are congruent to each other, but not the third pair of sides of those triangles, certainly not any of the angles. I mean, look at the angle between these two sides compared to the angle between those two sides. They don't appear to be congruent at all. All right. But how about three pairs of congruent sides? So that's another no. Three pairs of congruent sides? Well, here's a picture where truly every pair of sides that I have marked congruent is congruent. And tell me if these triangles as a whole look like they are congruent to each other. Do you suppose that I could spin this second triangle around or flip it upside down or whatever and move it over into position so that it fit perfectly on the other triangle on the left? Don't those triangles as a whole really look congruent to each other? Doesn't this obtuse angle up here really appear to be congruent to that obtuse angle down there? Doesn't this really skinny acute angle, it's not getting marked because my stylus is not cooperating, doesn't that really appear to be congruent to that skinny acute angle there? And then finally, this other acute angle, which is a little bigger than the other one, doesn't that seem to be congruent to that one? I hope that you're agreeing with me that they certainly do at least seem to be. Now, seem to be, as we've been saying since the beginning of the year, is rarely ever sufficient evidence to draw a firm conclusion. Okay? But now here's what mathematicians throughout the ages have discovered. Not a single one of them ever has been able to put together two triangles with three pairs of congruent sides and discover that, oh, wait a minute, these two triangles are not actually congruent to each other. I mean, billions and trillions of examples have been tried by mathematicians throughout the centuries, and every time they construct two triangles with three pairs of congruent sides, the triangles as a whole are congruent. Now, ordinarily, billions and even trillions of examples is not enough evidence for mathematicians. They want final proof of all possible examples. But in this rare case, mathematicians were willing to make an exception. And actually, this exception was made thousands of years ago, really before even billions and trillions of triangle pairs were tried. Okay. Mathematicians that long ago in history had the sense, the correct sense, in a way, that nobody would ever find a pair of triangles with three pairs of congruent sides where the triangles as a whole were not congruent. Okay, so this is a yes. Now, this is a yes. Three pairs of congruent sides is enough information for us to know that, okay, then, the triangles as a whole are congruent. Okay? We don't have to go measuring any of the angles. If we know that three pairs of sides are congruent, then we can say, all right, the triangles as a whole must be congruent. And then because of what our definition of congruent triangles is, then we could go on after that and say, so now I know that these corresponding angles are also congruent. Okay? 3 pairs of congruent sides. We abbreviate that like this. I'll say more about that abbreviation in a minute. But each one of those S's stands for a pair of congruent sides. So 1 pair, 2 pairs, 3 pairs of congruent sides. Well, there's other combinations of 3 congruent pairs of things in triangles that we could explore. Okay? 1 pair of congruent parts is never enough information to determine that the 2 triangles as a whole would have to be congruent. And even 2 pairs of congruent parts of the triangles is never enough. But 3 pairs of congruent parts is sometimes enough, sometimes not, depending on what kinds of parts you have. And let me scroll back up and take you back to this question right here. 3 pairs of congruent angles. That should have said congruent angles right there. That's a no. Okay. And again, we would abbreviate that something like this. If you have 1 pair, 2 pairs, 3 pairs of congruent angles in 2 triangles, that's not really enough information or the right set of information or evidence, if you will, that the triangles as a whole are congruent. And here's my example showing that, look, I've got 2 triangles with 3 pairs of congruent angles, but one triangle has much larger sides than the other. Okay? So 3 pairs of angles, not good enough for us. 3 pairs of congruent sides, that's good enough. What if we mix up some sides and some angles? Or combine some congruent pairs of sides with congruent pairs of angles, and we have 3 total congruent pairs of parts. How many different ways could we do that? Well, here's a couple of examples. What about 2 pairs of congruent angles and 1 pair of congruent sides? That's 3 total pairs of congruent things. Would that be enough? So here's a drawing with 1 pair of congruent angles and a 2nd pair of congruent angles and a pair of congruent sides. Okay. And those triangles certainly appear to be congruent. And I can tell you again that yes, that's a yes. That's enough information to establish that all the other pairs of sides and the remaining pair of angles must also be congruent. And here's another drawing that's a little bit different from the first one. I'll explain in a moment. But let's just realize that here's 1 pair of congruent angles marked. Here's a 2nd pair of congruent angles marked. And here is 1 pair of congruent sides marked. So both of these illustrations in this row here are illustrations of 2 pairs of congruent angles and 1 pair of congruent sides. But we refer to these situations differently. Do you see any difference among these pairs of triangles, the way they are marked, that would suggest something importantly different to mathematicians? Again, they both have 2 pairs of congruent angles. They both have 1 pair of congruent sides marked. But there is something that really is of consequence to mathematicians. It matters. Okay? Here's the deal. In these pictures on the left, notice, I'm going to get my highlighter here. Notice that, let me not draw it that way. Let me erase that. The one side that is marked in each of these triangles is, in a sense, connected to both of the angles that are marked, or it is touching both of the angles that are marked. Or another way to say it is that side is part of each of the angles that are marked, right? If I traced one angle, it would include that yellow highlighted side. And if I traced the other angle, it would include that yellow highlighted side. Here's the word we use most often in describing this situation. We say that the one side that is marked is between the two angles. It is immediately, directly between the two angles. Now, I will admit, I think that word between is a little vague and it can be a little confusing if you don't understand the meaning properly. Okay, but that's the word we commonly use. But I think the more accurate way to describe it is to say that one side that is marked is a side that is necessary to form each of those angles. It's included in both of those angles. Okay, and so we would describe these three congruent parts by this abbreviation, SAS. This S stands for a pair of congruent angles. This S stands for another pair of congruent angles. And this A, being in between the two S's, stands for, oh shoot, that's not SAS. That's totally wrong. A. That's what we've got there. All right. My apologies. Let me start over. This A stands for one pair of angles that's marked congruent in this picture. This A stands for a second pair of angles that's marked congruent in this picture. And this S, being in between these two A's, stands for a congruent pair of sides where the side is between the marked angles, or part of both of the marked angles, touching both of the marked angles. Whereas over here, we would describe this situation as AAS, one A for a pair of congruent angles, a second A for a second pair of congruent angles. But this time we've written the S not in between the two A's, but to the side of the two A's. And really, it doesn't matter whether you write AAS or SAA. That really wouldn't matter to mathematicians as long as the S is not in between the A. Okay. But this AAS is how we usually write it, and we write it that way to indicate that the one side that is marked is not between the two angles that are marked in that triangle. And again, what we mean by that is that this side here, let me get my highlighter again. Let me just get a different color pen. This side is part of that angle over there, but it's not part of this angle over here. That side is not necessary for this angle. It's not part of that angle. It's not touching that angle. So we say that side is not between these two angles. Okay? The one side that is between the two angles in that picture would be this side here. That's the one that's between the two angles. It's touching both of the angles. Okay? So both of these situations are good enough evidence to determine that, okay, the triangles as a whole would have to be congruent, but we describe them differently. Okay, so this is a yes, and this is a yes. And scrolling back up just a bit, SSS was a yes, and AAA was a no. Okay, so we have two more combinations to look at, and they both involve two pairs of congruent sides and one pair of congruent angles. Okay, so here's a situation, and this would be written, now let me go back to my red pen. This would be described as SAA. AS, this would be described as SSA. And again, the difference is the location of the A compared to the two S's. In this case, the A is in between the two S's, because this one angle that is marked is an angle whose sides are the two S's, the two sides that I've marked congruent in the triangle. Okay? Whereas in this picture, this angle is not in between those two sides. The angle is outside of those two sides. Okay? It's off to the side, so to speak. Okay? And this situation is a yes. And again, what I mean by that is, if we have this collection of evidence, we can be certain that the triangles as a whole are congruent, whereas this situation is a no. Okay? And let me spend just one more minute on this situation here. I've actually got 3 triangles drawn over here. You see them? 3? These 2 certainly look like they are congruent to each other. I have one pair of congruent sides. I have a second pair of congruent sides. And then here's a pair of angles marked in those triangles, which are not in between the sides. And those triangles look like they are congruent to each other for sure. But my stylus pooped out on me again. Let's compare this triangle here to this triangle here. Now notice, I have marked this segment congruent to that segment. Didn't do a very good job highlighting those segments. This one congruent to that one. Now I will tell you, those 2 segments may not look congruent to you, but they are. I built them so that they are truly congruent. If you took a ruler, like right now, you put a ruler up to your computer screen and measured this segment length in centimeters or millimeters and measured this one, you would find them to be the same. If you think that this one here is shorter, it is an optical illusion that maybe many of you have seen before. It is truly congruent to that segment there. I challenge you to put a ruler up to your screen and measure them. Okay? Likewise, this segment here that I have marked congruent to that one really is congruent to that one. Those 2 sides really are congruent to each other. Again, I challenge you to measure them. And furthermore, this angle is congruent to this angle. So here are 2 triangles that have 2 pairs of congruent sides and a pair of congruent angles, and the angles are not between the sides. The triangles themselves are clearly not congruent as a whole. Okay? So that's a no. And that's all the combinations of 3 pairs of congruent parts we could test out. To review, what are sufficient sets of evidence to guarantee that 2 triangles are congruent? In other words, again, we're assuming we're in a situation that we don't know if 2 triangles are congruent. Nobody has told us that they're congruent. And we have a little bit of evidence. We have some congruent parts marked in the triangle, but not all of them. Well, if we have 3 pairs of congruent sides marked, that's enough evidence to say, okay, the triangles as a whole are congruent. If we have 2 pairs of congruent sides marked with the angles congruent that are between the sides, that's a good set of evidence. If we have 2 pairs of angles marked and a pair of sides that is between the angles, or a pair of sides that is not in between the angles, either one of those sets of evidence is okay. But I will just be right up front with you. We are just not going to concern ourselves with this situation for the rest of this semester. This whole idea of SSS, SA, 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 how they look different, what they mean, it's complicated enough, I think, without us considering every possible combination. So this is one that we're just not going to talk about anymore. But you do need to know that these three combinations are good and that these two combinations are no good. Okay? And so what that leads us to now is three more reasons that we can use in proof problems. So here's an updated set of reasons. Next time you're doing a homework assignment, like the homework assignment that goes with this lesson, have this updated yellow box open or printed while you're doing the homework problems. And on the second quiz in this unit, which is not coming for a little while, make sure you have this up-to-date yellow box open while you're taking that quiz. Okay? And the new reasons are down here. Okay? And they are in the form of if-then statements, as always. If SSS, that's a serious abbreviation, but you got to know what it stands for. Okay? It stands for 3 pairs of congruent sides. And you need to know what each of these abbreviations stands for. I do want you to use these abbreviations when you're writing out these reasons, but you have to know what they stand for. You have to know how they're different. Okay? You cannot just use any of these 3 reasons when you're trying to prove in a problem that triangles are congruent. You have to use the correct reason. So let's do a couple of homework problems like the ones you're going to see on tonight's homework. Okay? So in this problem now, and in all of the problems on tonight's homework, the proofs go beyond a step 2. They go on to a step 3. Okay? I'm asking you to prove in this first problem here that angle C is congruent to angle F in this diagram over here. But the fact that I have laid out a step 2 and a step 3 suggests very strongly that we're not going to be able to prove this in step 2. Okay? It's going to take us until step 3 to accomplish this proof. All right? And so in step 2, we're going to have to look for something else that is provable, something else that we can conclude that hasn't already been given to us. Okay? I'm going to be honest with you. These proofs, these 2-step proofs, in my opinion, are not just like a step more complicated than the proofs that we have been doing. I think they're more than a step more complicated, if you catch my meaning. All right? This is going to take some hard thought and work, and we're going to talk about these a lot. Okay? Over the next few lessons, I don't know that we're going to add one more reason to this list. We're just going to keep doing proofs that are more than one step, and we're just going to keep getting better at them and better at them. So this homework assignment might be a lot more difficult than the homework assignment so far in this unit. It might not. All right. I don't want to make anybody panic. Okay. But if it's feeling a lot more difficult, I don't want you to get overly frustrated and lose hope. And again, say to yourself, I have no idea what's going on. I'm never going to get this. Don't say that to yourself. Okay. So here's what you need to start doing in these proofs that you haven't had to do before. See all this given information? AB is congruent to DE. Notice there are no marks in the diagram, showing us that information. The information has been stated, but it has not been illustrated. I think you should add congruent marks to the picture. I think you need to add congruent marks to the picture to make any progress in the proof. Okay, so I'm going to mark AB congruent to DE. And the second statement that's written but not illustrated, I'm going to add marks to the picture. AC is congruent to DF. All right. Now, let's use a different set of congruent marks than I used on the first pair of sides. Don't use a single pair of congruent tick marks again. That's going to create confusion. Okay. I mean, here, I should have gone even more slowly. If you use the same, if you use single marks in the first pair and single marks in the second pair, and now you cover up your written statements and you go look at the picture, it looks like you've marked 4 segments all congruent to each other. And that's not what the written information is telling us. Okay? So anytime you go to mark a new pair of congruent objects, make sure you're not using identical marks that you've already used. Okay? Last piece of given information, angle A is congruent to angle D. So I will put a single arc in there and a single arc in there. Okay. Now the picture has caught up to the written information. Okay. And again, my goal is to prove that angle C is congruent to angle F. But there is no way to do that in step 2. Now here's another tip. Okay. And I'm going to write this down because this is so important. In every proof problem from now on, you will have to prove congruent triangles at some point. Okay? In every single proof problem that you get assigned from here on out, I think without exception. Okay? Maybe there'll be an exception, but I'm not planning any exceptions. Okay? You're just going to have to prove congruent triangles at some point. Why is this such an important idea to keep in mind? Because if I don't give you that there are congruent triangles in the picture, you need to say to yourself, okay, Mr. Nortillo promised me I'm going to have to prove congruent triangles. Even if he didn't ask me to prove congruent triangles, he told me that I'm going to have to prove congruent triangles in order to prove the thing that he asked me to prove. Okay? And here are your 3 ways of proving that triangles are congruent. You need to get one of these 3 sets of evidence in place in the problem. And then you can say that you have congruent triangles, and then you'll be able to go on and perhaps finish the proof if there's more to do after that. Okay? So, in this statement number 2, I'm asking myself, is there enough information here to prove that I have 2 congruent triangles? And remember, here are the 3 ways to do it. Do I have SSS in this picture? Do I have 3 pairs of congruent sides marked? Do I have 2 pairs of congruent sides marked and a pair of angles in between them? Or do I have 2 pairs of angles marked congruent and a pair of sides in between them? Well, I think you can see I have this information. Okay, so I can say that triangle ABC is congruent to triangle DEF. And the reason I must provide is if SAS, then triangles are congruent. Okay? Because now that I have established that the triangles as a whole are congruent, now I can use this reason, which we were using in the last homework assignment. Okay. We can claim that angle C is congruent to angle F because if triangles are congruent, then their corresponding parts are congruent. Okay? Let me go through this self-checking business with the proofs as I've been doing from the beginning. Okay? Let's change colors here. Remember, every reason has to have the evidence for that reason in a prior statement or statements in the proof. We need to be able to circle the hypothesis of every reason, SAS. Do we have SAS in a prior statement or statements in this proof? Well, yes. Here's a pair of congruent angles. Here's a pair of congruent sides. And here is the other pair. Oh, why is my pen not cooperating? Here, come on, stylus. Here is the other pair of congruent sides. Okay. And then for the next reason, if triangles are congruent. Okay. Do we have that said in a previous statement? Yes, we do. Okay. But do you see how we would not have been able to use this reason in step 2 because we did not yet have a statement in the statement column saying that we had congruent triangles. Okay? You can't start a reason with if triangles are congruent until you have a statement saying triangles are congruent. Okay? Because this hypothesis must be something that is already true. Right? Let's look at one more example. Problem number 1. No, not problem number 1. This should be problem number 2. Sorry about that. That should be a number 2. Prove that triangle TOY is congruent to triangle TAK. Now, once again, this tip over here in every proof problem from now on, you'll have to prove that triangles are congruent at some point. Okay, well, that is what I'm asking you to prove specifically in this problem. Be on the lookout in tonight's homework. There are some problems where I am ordering you to prove that two triangles are congruent. And then there are some homework problems where I'm not ordering you to prove that two triangles are congruent, but you will have to prove that triangles are congruent before you can prove the thing that I'm asking you to. Okay? Keep that in mind. Now let's go through this second example here. Prove that these two triangles are congruent. I remind you, we're looking for one of 3 possible sets of evidence that is sufficient to conclude that the triangles must in fact be congruent. And here they are, SSS, SAS, and ASA. Let's look at the information that has been given to us. Okay. Angle TOA congruent to angle TAO. You need to mark that in the picture. Gosh, you need to make this a habit. Anytime you write down congruent things or see congruent things given to you that it's not marked in the picture, you've got to get into the discipline of marking the picture. Okay? That may not seem crucially important on this homework assignment, but it absolutely will seem that way to you in the near future, I'm sure. Although, quite honestly, in this problem right here, I don't know how you get anywhere if you don't add these congruent marks to the picture. So angle TOA, that's this one. Congruent to angle TAO, that's that one. What's the next piece of given information? TY is congruent to TK, those segments. So TY is congruent to TK. And then YO is congruent to KA. Use a double tick mark, not a single, because we've already used a single. And what am I trying to prove? That triangle TOY is congruent to triangle TAK. Triangle TOY. Trying to prove that that triangle is congruent to triangle TAK. How many pairs of congruent things How many pairs of congruent parts of those triangles are currently marked? How many pairs? Not 3. Only 2. Right? These angles that are marked congruent here, those angles are not parts of the red triangles. They're outside of the red triangles. They're not parts of the red triangles. Right now, I have a pair of congruent sides in those 2 red triangles and a second pair of congruent sides in those 2 triangles. That's not enough information to conclude with any certainty that those 2 red triangles are congruent. I'm going to need either a third pair of congruent sides or the angles that are in between those marked sides. I'm going to have to somehow establish a third pair of congruent parts, and then maybe I can prove that the triangles are congruent. Okay? Well, if I'm going to try to prove that the angles between the sides are congruent, I'd be trying to prove that this angle over here is congruent to that angle over there. Well, I'd need a good reason for that. If I was trying to prove that a third pair of sides is congruent, I'd be looking for a way to prove that this segment is congruent to this segment. And I'd need a reason for that. Any thoughts about proving that these angles must be congruent or proving that those segments must be congruent? Well, here's what we need. We need this reason here. Okay. If a triangle has 2 congruent angles, then it has 2 congruent sides. I'm talking about triangle OTA. Look at that triangle in the middle of this picture, triangle OTA. It has 2 congruent angles marked in it. And so therefore, because it has 2 congruent angles marked in it, something that we were given, the hypothesis of that reason is something that's already true, then that triangle has 2 congruent sides. And what are the 2 congruent sides? TA is congruent to TO. Okay. And now go mark those segments congruent. Now that we've written that they are congruent and given the reason why we know for sure they are congruent, let's go add congruent marks to the picture. I'm going to erase those blue segments there and those blue angles there and that there and put in congruent. I want the red pen. 1, 2, 3. 1, 2, 3. Now, in the triangles that we are trying to get to be congruent to each other, we have 3 pairs of congruent sides marked. So we can say triangle TOY is congruent to triangle TAK because if SSS, then triangles are congruent. Now, once again, let's self-check. Do we have 3 pairs of congruent segments named in the statement column before step 3? Well, here's one of them. We didn't have it until step 2. And then here's one of them that was given to us. And here's the third one that was given to us. Okay? So only 2 of them were given to us, and we had to come up with the third. This has been a long video lesson. I can feel it, right? I didn't expect it to go this long, but this is a big, big lesson, okay? Fortunately, you've got 3 days to try to do this one homework assignment, right? Put some time into it. And again, if it's feeling really difficult and complicated, don't panic, All right. Because this is all we're going to be doing for the next several lessons. And like I said, I don't think we're adding any more new reasons. It's just practice, practice, practice. The proofs are going to get even a little bit longer. They're going to go beyond a step 3. Some proofs will require a step 4, even a step 5. Right? But I think you're going to be able to handle that as every day and every homework assignment goes by, and as we talk about this some more. All right. So give the homework your best shot. Message me or your teacher if you've got any questions before the next class, and come to class with questions ready to ask if you have them. Okay. Good luck.